Good evening, I'm your host Phil K of The Amazing Race, and tonight is the finale. We're down to two final teams, brother and sister Hunter and Scarlett, and best friends Lisa and Ashley. Let's meet the competitors.
Hey everyone, I'm Hunter. This is my big sister Scarlett, and currently I'm a student at Clemson studying English. And good thing AP Stats are mostly writing and logical thinking, because let's just say numbers really are not my thing.
Speak for yourself, Hunter. I love math. My favorite part of high school is my statistics course, and I love calculating probabilities and punching data into my calculator. In fact, I love math so much I continued to pursue statistics in college. And now I'm a market research analyst who uses stats in my everyday job.
That looks like a pretty tough team to beat. Let's see who they're facing for the grand prize of extra credit in Mr. Scott's class.
Hey guys, I'm Ashley, and I can't wait to blow the competition away. I also have a heavy background in statistics because I work as a meteorologist and took many stats courses in college. These guys don't have anything on us. My high school AP Stats class prepared me fully for tough college courses and helped me to better understand some of my science classes as well.
I'm Lisa, and we are best friends. Although we have many common interests, our love of statistics are definitely my favorites. I work as a financial analyst and use statistics every day to solve problems.
Alright, now that we're familiar with the finalist teams, it's time to begin the race for the grand prize and ultimate statistics bragging rights. Our competitors will race at different obstacles around the school and competing in challenges testing their knowledge of statistics. The team who reaches the final destination first will be crowned the champions of Amazing Race and win the extra credit. Each team will be given a clue to where the first challenge is. The final race will begin.
That's easy. In my statistics class, we learned all about kinds of graphs that show qualitative and quantitative data.
Quantitative is the measurable one, and qualitative is categorical, right?
Yes, but that's not the point. This graph is called a stem and leaves plot. That must mean the first challenge is in the garden.
Let's go!
Okay, so I know this is a graph displaying data about the sample, but what is it even talking about? Do you think we should start by finding the mean, median, mode, and standard deviation?
I'm not sure. I think those are always to describe quantitative data with numbers. But this is a graph. I think I remember my favorite teacher, Mr. Scott, calling this graph a stem and leaf plot.
You're right. Stem and leaves? The challenge must be in the garden. Let's go!
Yes, looks like we're the first ones here. Let's see what our challenge is going to be.
Since you have demonstrated some basic knowledge about displaying data in graphs, it's time to test your knowledge of modeling distributions of data. The heights of the population of sunflower plants follow a normal distribution with mean 145 centimeters and standard deviation 22 centimeters. Find the z-score of this sunflower and the probability that any sunflower is as tall or taller than 160 centimeters. Okay, let's do this. The problem says it's a normal distribution, so we can use the calculator program, normal CDF.
But wait, don't we have to find the z-score? Let's use our z-score formula.
Yes. Like the z-score formula of mean over the standard deviation. Let's put those numbers in.
I got the z-score.
Hurry up, Hunter, they're catching us. Now that we have z-score, let's put it into the normal CDF program.
Is there
So,
need to do that now? Or?
find the probability that our z-score is going to be greater than or equal to our z-score, which now you can start typing it into the calculator.
Hunter?
So we set our lower bound at the z-score and our upper bound at infinity. And since the z-score, it always has a mean of 0 and a standard deviation of 1. I think I know it's 0.48, which is 24.8%.
That's right.
Really, 24.77 of the sunflowers in the garden should be as tall or taller than our sunflower. Modeling distribution was my favorite chapter in my high school statistics class because I was taught all kinds of programs on my calculator such as normal CDF, inverse norm, and even one variable statistics. If you take AP Statistics, you should learn how to better use your calculator to make life so much easier. The best part is you will always have access to your calculator for tests and quizzes.
You're so right. All right, so let's find the next clue so that we can get to our next challenge. First, remember, we only have one more challenge to win before racing to the final destination and competing for the grand prize. Let's go.
Deliberately imposing some treatment on an individual to measure their responses. That's so random.
Hey Lisa, isn't that the definition of an experiment?
Oh yeah, let's go to the science lab.
You're right, let's go.
You know, I think I remember this from the chapter about designing studies. Do you remember that chapter? It involved a lot of writing and super little math. And we figure out how to take samples and design surveys for our experiments.
Experiments! That's it!
Yeah, we should head down to the science lab to see what our next challenge is.
Let's go!
Okay, so the challenge says, what kind of conclusions can you draw from an experiment with random assignment and random sampling?
Well, the definition of random assignment is using impersonal chance to assign experimental units to treatments. We use this in experiments in which we are assigning individuals to treatments to measure how they respond.
Wow, I didn't realize how much statistics are in every job, even becoming a scientist. I'm so glad that I took AP Statistics in high school so that I can pursue all kinds of careers in the future.
When we have random assignments, we are able to draw conclusions about cause and effect.
Oh, that's true.
I know random sampling. There are a few methods like simple random samples, stratified random samples, cluster samples, and systematic samples.
Yeah, and with random sampling, we can extend our inclusions to the entire population, not just our sample size.
So, with both random sampling and random assignment, we can draw conclusions of cause and effect about an entire population.
All right, now the race is really on. Let's find the final clue that will lead us to our last challenge.
I see something. It's a Skittles wrapper. What could that mean?
Let's go to the place where we can buy Skittles. Let's go, the lunch room.
Yeah.
This bag of 100 Skittles contains 15% red Skittles, 18% green Skittles, 33% purple Skittles, 12% yellow Skittles, and 22% orange Skittles. Additionally, 20% of all the Skittles in the bag have a defect. Find the probability of picking a red Skittle given it does not have a defect.
That's a toughie. What do you think we should do? Let's draw a tree diagram.
Yes.
Working
Great
together.
idea.
Yeah, we're doing inter-team mingling.
This problem is just so difficult. So, first we should probably start with the probability that it does have a defect and that it does not have a defect. So, if 0.2 have a defect, then 0.80 do not have a defect. So then, we should then separate them into the colors. So, half of them are red and the others of them are not red. So, if 0.15% are red, then 0.85% are not red. So then, to calculate the conditional probability, we need to multiply 0.15 times 0.80, leading to the answer of 0.12. So 12%.
That's awesome. So 12 Skittles.
That's wrong. No, because it's a 100.
Oh, you're right. So 12 Skittles are red and have a defect.
Yes. We solved the problem. Great job, everyone.
Congrats, everybody. It's a tie because everyone's a winner, and thank you for watching The Amazing Race. I'm your host, Phil K.
Have a great night.
All right! Woo! Good